Dear students, today we see about the experiment name is determination of transmissibility ratio by using the vibrating table. Aim of the experiment to determine the transmissibility ratio by using the vibrating table. Apparatus required, experimental setup and spring and speed and vibration indicator. So this is the experimental setup. The sensor is connected to the spring is connected to the sensor, and the sensor is connected to the vibration indicator, and then this is the speed regulator. This is coarse and this is one is fin. This is the vibration level. So this is the experimental setup. Now we going to see the tabulation and formula. So this is the schematic representation of the experiment. So here we see the load cell. This load cell connected to the spring. Spring is connected to the shaft. So the shaft is connected to the motor. So this motor load is applied to the spring, and spring load is converted and transferred to the load cell. This load cell is connected to the indicator. This indicator, it will blink on the how much load is applied to the spring. So this is the base frame. So this is the base frame, and then this all setup is fixed on the base frame. So next we move on the spring details. A coil diameter 3 mm and outer diameter 20.5 mm. Number of turns is 4 and stiffness is 37784 Newton per meter. And now move on the tabulation. So this is the speed of the motor. So we going to gradually increase the speed of the motor. At the time, how many LEDs are blinked? That means a number of LED blinked in the display, and then force transmitted we are going to calculate, force exited we are going to calculate. The transmissibility ratio means force transmitted divided by force exit. Force transmissibility ratio is equal to force transmitted divided by force exited. Force exited is equal to mass into omega square into E, and then force transmitted is equal to 0.125 into this value is constant value for 0.125 into number of blinking, and natural frequency omega is equal to k root of k by m. So from this formulas we are going to calculate transmissibility ratio. Now we move on the experiment. Now the power supply is switch on, and then the wire connections are already we given. So now we gradually increase the speed of the motor, and the value is displayed in the RPM. So here 356 RPM we given. So number of LEDs blinking means 1. So now we increase the force applied to the spring and increase the RPM. So this is the force vibrated, and the spring is vibrated. The load is transmitted to the load vibration indicator. So here one LED is blinking. So and we going to increase the second level speed. So this is the second level speed. We increase the load of the spring. Now we blinking the second LED, and now gradually increased, and then third LED is blinked. We gradually increase the speed. Now all the LEDs are blinked. That means we reach the maximum vibration. So we so only the LEDs are blinked. So now we going to calculate by the tabulation and to find the transmissibility ratio. So result that's the natural frequency and transmissibility ratio determined by given vibration table. Thank you.